In this last video of this series, we're going to talk about events and we're going to actually spawn our enemies and finish our small game. In our game, we will use events to inform our enemy controller to spawn more enemies when we kill one or more enemies using our weapon, so that the game will be infinite, well, until we eventually die. Before we can use our events, we need to create our enemies. And to do that, we need to go to our Projects tab, Prefabs, and here we have the enemy prefab. Now this enemy prefab is just a game object that you can drag to your game, your scene view, and add the enemy to your game. Now I'm going to select it and press delete key to delete it, but what we need to do is go to our enemy controller because it will want to spawn our enemies and it needs to know how. So let's go to our script in our inspector. And let's see, we have this enemy prefab that is none or null in terms of C#, and we need to assign it. So let's go to our Projects tab, and from our prefabs, let's drag our enemy. Now, do be careful because if you click on something else, this will disappear. So you need to go to our prefabs first, to the folder, next select the enemy controller, and only then drag our enemy to the enemy prefab slot. Okay, when you have that, let's go to our scripts folder. And let's reopen our enemy controller script. Here, what we want to do is go to our spawn enemy method, and after we get the position of our random position to spawn our enemy, we're going to delete this debug.log statement, and instead we're going to call game object. So this is a game object in our scene view. We're going to reference it by calling this enemy with capital O object equals, and what we are going to call here is instantiate with capital I, instantiate. And you should already see the auto completion, so let's use it. Pressing enter, open parenthesis, and we are going to pass underscore enemy prefab as the first argument. We're going to add comma because we want to spawn it at a specific position. So spawn position that we have above, and last parameter will be that we move this line to the new line. And we are going to pass as the third parameter quaternion with capital Q dot identity, which is basically rotation 0. We are not going to talk about quaternions in this video. This is pretty complex topic, but just know that this creates our objects. So this is called instantiating prefabs at runtime, and basically we call instantiate my prefab, the position, and quaternion dot identity so that it has 0 rotation. Okay, great. Now we have created this enemy at the random position, so we should be probably able to save the script Ctrl+S and go back to Unity and press play. Okay, so when we do, we should see now that we have some enemies in our game view. But didn't we specify that we want to have 5 enemies? Well, let's check it out. We're going to select in the scene view our enemies, and we can see that here is one. I'm going to use the move tool, and let's move it. It is single enemy. Let's select another one. Here it is. And here you can see that this enemy and this enemy were both at the same position. So this is a pretty big problem. Now obviously another problem is that none of those enemies is moving towards our player, so we need to fix both of those. Let's stop our game. Let's first fix the problem with spawning. So let's go to our scripts folder and let's reopen our enemy controller script. Now let's find the select random position method. Let's slide to the bottom where we have this return statement, and we are going to return selected transform.position, and we are going to add plus. We are going to add 2 vectors together. We are going to call random dot inside with small case I inside unit circle. You should find this here, and now it will generate as a vector to return a random point inside or on a circle with radius of 1. Now this will add some offset to our position, so we have those enemies spawned in different places around this position. But we have some error here. If we hover over it using our mouse, we can read operator plus is ambiguous on operands of type vector 3 and vector 2. So we can't really easily add vector 3 to vector 2 because we do not know what is the z value, so how can we add it? What we can do is just add in front of this inside unit circle parentheses. And just as we did cast the enum to an int, we can cast a vector 2 to a vector 3 by typing vector 3. To learn more about casting and conversion, I will leave this link to the casting and conversion C# programming guide so you can read more about this topic. In terms of our script, we can Ctrl+S to save our script and go back to Unity and press play. Okay, and now we should see that our enemies are spawned in different places close to the same position. So this is what our additional code did. Now we can see them separately and we have indeed 5 enemies spawned. Let's stop our game. And now we need to make them move, so we need to create a new script. Let's go to our Projects tab, Scripts folder, right-click here, create a new C# script. Let's call this enemy. And let's open this script up. This script will be pretty similar to our player script, where we have used rigid body 2D for movement, we have the speed, but we are not going to access the input from our keyboard. Let's go back to our enemy script. You can select those scripts at the top if you have them opened in Visual Studio. All of those should be available for you. So, in our enemy script, we are going to add at the top of our class some serialized fields. So, serialized field, and we are going to create here private, float, underscore speed, and by default this will be set to 1. Next we are going to create private, rigid body, 2D, underscore RB2D. Now this will not be serialized field, I will show you a different way of getting access to it. Next, to calculate the input value, we need to know where the player is, and we are going to just get the direction towards the player. To do that we need to create private, transform, because as you recall, transform object contains a position. So if we get the transform of the player, we can get the position towards the player or direction towards the player. So let's call this underscore player with capital T transform. And next we are going to create public bool stopped with capital S equals false. This will be public because we want other scripts to be able to stop our enemy if we want to. Lastly, we are going to have a serialized field, and we are going to create private game object, so capital G, capital O, and this will be called underscore crab dead with capital D. The idea is that we are going to have a prefab called crab dead because it will be much easier to create this where our enemy was, and the crab dead has the sprite render. Actually, we need to select it and change the order in layer 0 because otherwise when we drag it onto our scene view, it would be shown below the ground. Let me delete the crab dead object from our hierarchy using the delete key. But crab dead will also have a sound that will be played and destroy with delay script that will cause this to disappear after I think 5 seconds or 3 seconds. You can explore the script on your own. But for now, let's go back to our enemy script. We have all the variables. Now we need to grab the reference to our player and to the rigid body. So first of all, what we can do is call in the start method underscore RB2D equals get with capital G, capital C component. And we are going to pass in the triangle brackets rigid body, so the type 2D, close the triangle brackets, open and close parentheses, and add the semicolon. So in our case, our enemy prefab has the rigid body. Our player had the rigid body and we have dragged it to the RB2D field. Now in our enemy script will automatically get the reference to the rigid body 2D, or if it is not present, it will obviously get null. So back in our script, we had received this rigid body 2D. We also need to get the player transform component. So what we can do is call our underscore player transform, and we have another method to get an object reference in Unity called find any object by type. You should already have the auto completion, and we are going to pass in the triangle brackets type player, and we are going to close triangle brackets and open and close parentheses. But now we are going to have an error. Cannot implicitly convert type player that we are getting to a Unity engine.transform. What this means is that we need to get the dot transform here. So now we are going to get the transform from this object. Now the problem would be that this method find any object of type can return null because it can find no player object in our scene, in our hierarchy. So now it would be much wiser to create player equals and just cut this piece of code out of this line and Ctrl X and paste it Ctrl V here. So now the player is null or not. So we can check if our player is not equal, so exclamation mark and equals null. This will check if this is not null. In that case, we are going to add curly brackets and we are going to cut this line out, paste it here, and we are going to say player or transform equals player dot transform. Else, if we do not find it, we can type else, open curly brackets, we are going to type stopped equals true. So we can't really can't really move if the player transform is null. We can't really find the direction to our player. We could add a similar statement for the rigid body in case rigid body is null, but we know already that we have rigid body on our enemy, so we are safe with this. Okay, we have all the data that we need to create in the update method. We are going to call here move, open close parenthesis. If something else was created for you, if Unity or Visual Studio has suggested some other name, you can just delete this, and we are going to call move, open close parenthesis and add semicolon. And again, we are going to right click, quick action on it, and generate it as a new method. Okay, now here we are going to pass the movement method or give it a movement method for our enemy. So we need to check here first. Let's delete this throw new and not implemented exception. We're going to check if, and we need to check if we are stopped. Or to add or, we are going to add two vertical lines, and we are going to pass here that the underscore player transform is equal to null. So in case our player transform is suddenly null, if we destroy our player object from our game and it can't be really accessed anymore, we are going to add curly brackets and we are going to type underscore RB 2D dot velocity, just like we did with the player, equals vector 3 dot 0, and add semicolon, and we are going to use return to return early from this method. In Visual Studio, we can compare multiple conditions in an if statement using, I think those are called ampersand signs, and we can give a condition X and condition Y, and those two ampersand signs are called conditional AND. So if X and if Y is true, only then our if statement will run. On the other hand, we have also conditional OR, so two vertical lines, and this will be X or Y. So if X is true or Y is true, then our if statement will run. So in our code, if player is stopped, or if our player transform is equal to null, in case of any of those conditions is true, we are stopping the movement and we are returning from this method. Only if both of those are false, so we are not stopped, and the player transform is not equal to null, so we have a reference to some transform object, we're going to continue. So we're going to, actually we don't need to add else statement because we are going to use return to return from this move method back to our update. But if we do not return, we can continue writing our code. So here we are going to type vector 3 direction to player equals, and we are going to get the underscore player transform dot position, and we are going to subtract from it our transform, so the transform of this object dot position. Let me move it to the next line and add a semicolon at the end. So here is just math. We are calculating the direction from the enemy to the player object. We are going to use it for movement. So let's add below this underscore RB2D equals dot velocity, and this time we are not going to make a bug. We are going to call direction to player dot normalized, and this will normalize the direction to player vector 3 to have a magnitude of 1, and we are going to multiply this by underscore speed to have control over how fast our enemies are moving. Previously we have set the velocity in fixed update. I'm using update here because it is possible, but usually we want to use a fixed update for interacting with physics engine. But one more thing that is left is what happens when the enemy collides with our weapon. So we need to add a new method here. Just below the move method, we are going to call on trigger with capital O and capital T, and you should have on trigger enter to D. Let's press enter. Let's select it using our mouse and let's press enter. And Unity should create this for us because it is pretty lengthy method to type by hand. And we are going to type here if our collision, so this argument that we take here in collision dot compare, and we should have compare tag suggested by IntelliSense, and we are going to open parentheses, and we have string tag that I'm going to call in the quotation marks capital W weapon. Okay, make sure to type it just as I did, and open curly brackets, because here we are going to call instantiate, and we are going to instantiate our underscore crab dead at the transform, so transform of this object dot position, so at the position of this enemy object, and we are going to obviously call quaternion dot identity because we need to, and this is just a rotation none, so 0 rotation. And because we have collided with the object of type weapon, I have missed one of those parentheses at the top, that's why there was an error. If we have collided with an object of type weapon with the tag weapon, we are going to call destroy. And this is what we use to remove a game object, component, or asset from our scene. So destroy, and we are going to, in the parentheses, type game object. Game object here is a reference to game object that our enemy script is on. So basically, this isn't anything new in terms of C#, it is more about the Unity and how we interact with physics engine. So on trigger enter 2D, we'll call this script when we have collided with the weapon, so enemy has collided with the weapon. If the object is of type weapon, if it has tag weapon, we're going to destroy this enemy and instantiate our dead crab object instead. Okay, let's save this script, let's go back to Unity. In this series, I want to focus on C# language, so we are not going to explore how interactions with physics engine occur. If you are interested in this, feel free to ask me on Discord, the link will be in the description. Okay, we are done with our script. Make sure that it is typed as I have typed it, and if you have no more errors, let's Ctrl+S to save it. Let's go back to Unity. In the Projects tab, select the prefabs and our enemy object, and make sure to add to it our enemy script. So now, this will be of type enemy, and we are missing crab dead prefab. We can actually drag it from our prefabs folder. And actually, this is it that we need to do. We do not need to assign rigid body 2D because it will be automatically grabbed by our script. One thing that we need to check though is select in the hierarchy our player, expand it, select our weapon parent, expand it, and select our weapon. And we need to check if the tag is called weapon. If it isn't, we need to select add tag, and we need to type it in our tags, plus icon, and select weapon. I'm going to call this weapon _1. And now, if we go back to our weapon object in the hierarchy, we should be able to select it. But I have already the weapon tag assigned, so this should work fine. So let's press play. If everything went well, you should see the enemies approaching player. If we swing our axe at the enemy, the dead crab is appearing. And now, the only problem is that we are not spawning more enemies, and also, we can collide with the enemies and the player is unaffected. So we need to fix those issues. The problem right now is that the enemy spawner is spawning enemies, and the enemy only knows that it has died. So we need to exchange this information between the enemy and the enemy controller. It would be great if enemy could send a signal like a radio tower, I am dead or I have died, and then our enemy controller could be like a radio to receive this signal and act upon it. So do something like spawn more enemies when it hears that the enemy has died. In a nutshell, this is the idea behind events in C#. Make sure to stop your project and let's go back to our enemy script. So let's open it up. Now for the enemy to be able to send any signal to outside to some other script, we will need to add to here, just below the game object crab dead, we're going to add public. We're going to type event. And we are going to add action with capital A, action. And we are going to call this on with capital O and die with capital D. And semicolon. Now, if you have this underlined red, you are missing this using system. Now, actually, I have too many of those using statements, so I can remove some of those. So I only have this Unity engine. And now you can see that this is underlined red. Type or namespace action could not be found. Right click on it, quick action, and you should see using system, and it will appear at the top. And now we have this event action on die, so a signal that our enemy can send. actions are delegates, and delegates are used to store a reference to a method. It might be a bit confusing, but like public int a stores a value to 5, so the number 5, just like public rigidbody rb2d stores a reference to an object of type rigidbody or null, just like that our action delegate can store a reference to a method, so for example update or obviously null. But I think that it will be much easier to show you than explain what it does. So in our code, by default, this public event action onDie is equal to null. Now the event keyword just tells us that only this enemy can call this onDie method assigned to this delegate. So none other script can call it, just like we have discussed that if we make something public, like this public bool stopped, every other script can access it that has access to this enemy object. This event prevents other objects on calling this onDie method. Only enemy can call this event, can send this signal. So what we want to do is slide it down to where we have this onTriggerEnter 2D, and we have destroyed our object. So what we can do is create a new line and call if. Actually, we need to check if onDie, so our action delegate, is not equal, so exclamation mark equals null. So this is not equal to null, and we are going to open the curly brackets, and we are going to call onDie, and we can call parentheses because, as I have mentioned, this is a method. Now the great thing about it is that the enemy has no idea what it is calling. It is calling its own onDie event or action delegate. But if someone assigns itself to it, so some method like spawn enemy, the enemy object will not care. It will still signal that it has died. And this will be a very useful concept when you start learning about object-oriented programming. Another important part is that the onDie has no arguments passed to it. So we can't really assign to it onTriggerEnter2D because it requires us to send it a collider2D collision. We cannot really do that, so the method that we assign to it must be something like private void move, because move takes no arguments. So this is pretty important when it comes to events and action delegates. Let's save our script and let's go back to our enemy controller. I have it opened in Visual Studio, so it is appearing at the top of my Visual Studio. I can select it, but if you do not have it, just open it in Unity. Okay, now if you are in the enemy controller script, you need to go down to the spawn enemy method, which creates a game object of type enemy. Now we know that this object has enemy script on it, so we can create a new line and call enemy. Enemy. We will set it to be equal to enemy object dot get component, just like we did with the rigid body. Open triangle brackets, enemy, close triangle brackets, and add parentheses. Now again, we could check if enemy is not null, so exclamation mark equals null. Only in that instance, we're going to call enemy, and we can call onDie. And again, this is an action delegate, so we can assign to it equals our spawn enemy, and we are not going to pass parentheses because now it would not be possible. We need to delete those, and now we are going to see that we can't really assign it this way. This is because we need to use plus equals or minus equals on it. The idea is that a delegate is like a list. We can assign multiple method calls to it, so one event onDie from an enemy can trigger multiple methods on different objects. And that is the power of it, because it makes our code more flexible, because if we have a new sound system that plays some sound when the enemy dies, we can assign ourselves to onDie event on the enemy, and the onDie enemy, or the enemy itself, the script, doesn't have to change. Okay, so in our spawn enemy, we are going to use enemy.onDie plus equals spawn enemy. And now when the enemy calls onDie event, when it broadcasts this event, we are going to call this spawn enemy method that should spawn a new enemy and assign to the new enemy this spawn enemy method to be called when it dies, making this infinite loop where enemies keeps being spawned when one die, another is being spawned. Okay, this fixes one of our issues, but before we go test it, let's save our script, Ctrl+S, and I'm going to go to our player script. Again, if you do not have it opened in Visual Studio, open it through Unity, and we are going to slide it down just below the update method. We're going to again call trigger enter to the method, just like we did in our enemy. And we are going to call this here destroy. And we are going to call game object. But we also wanted to show some UI. So we are going to slide up to our player. And instead of using event action, we are going to use public Unity event. And there is something called Unity event. We are going to call this on player die. So the idea is the same. I don't know what other methods or objects will want to hear about player being dead. So I'm using Unity event, which is very similar to event action delegate that we have used for our enemy. But Unity event can be exposed in the inspector, so we can assign it through the Unity editor rather than through our code. So if you do not have this underlined, if you have it underlined red, probably you are missing this Unity using Unity engine.events. Now just right click on this quick action and using Unity engine.events, it will be added at the top. We're going to slide down to our on trigger enter and we are going to check if our on player die is not equal, so exclamation mark equal sign null. We're going to use the square curly brackets and we are going to call on player die, and I think we need to call this dot invoke because this is the way we call our Unity event. This is slightly different than event action delegate in C#. We need to call this using dot invoke method. Okay, that is it. Let's save our script. I think everything is saved, so let's go back to Unity. And now to finish our setup, we are going to select in the hierarchy our UI, and this object, if we expand it, you have this game object or game over UI. If you go to the inspector and check this checkbox, you will see that the screen got dimmer, but you have this TMP importer. We need to import TMP essentials. Sorry about that, I haven't included it in the package. But now when it is imported, you should see this game over text. Just close this TMP importer and go back to the inspector and uncheck game over UI in the inspector at the top to hide it. But what we will do is go to our player object, and now you should see this on player die Unity event showing up here. We can use this plus icon because we are not assigning it to it a method through code, but by hand through the inspector. So basically this is the same that our Unity event action delegate does through code. We're going to drag to it our game over UI from our hierarchy. Let's drag it to this non-object field. And now from this dropdown, select the game object and select at the bottom set active where that takes bool argument. And one benefit of using Unity events is that we can pass the bool using this checkbox. I want to set this active to be true, so I want to show this UI whenever our player loses. Let's disable it, and now we are ready to test our setup, so let's press play. Great. Let's try killing an enemy. And you can see a new one was spawned. Let's try killing another one. And the enemies are keep spawning. And if we collide with an enemy, you can see the screen game over, and enemies have stopped because player is no longer in the scene, so player transform is null. That's why that's why enemies are not moving. And that is it. Those are C# essentials that should allow you to code most of your games that you want to make. Now, if you want to learn more about Unity and C#, check out my video courses where we together create more advanced Unity projects. By purchasing those video courses, you're also helping me a lot and supporting the channel. By the way, I have mentioned that I will explain how to use the new input system at the end of this video series. Now, this is a pretty lengthy topic. Let me add a new video at the end that will explain how to create the new input system setup in our project, and I will link it at the end in this video. But for now, see you in the next video.